Welcome to NCERT math classes. Let's do some critical questions from the complex numbers. This is the part 4 of the video. Before this, I have made 3 videos and several shorts, okay, to give a preparation of complex numbers. Please go through all of them. Let's get into the part 4 critical sections. Okay, so if for a complex number z satisfying modulus of z minus 2 minus 2i is less than or equal to 1, the maximum value of modulus of 3iz plus 6 is attained at a plus ib. Then what is a plus b value? Okay, so if you look at it, first there are two equations given. First one is already inequality, which means we will get some uh, area on the argand plane, right? So what is that? Let's find out that first. Okay, so let z is x plus I by, then absolute z minus 2 minus 2i less than or equal to 1 is nothing but circle equation, circle inequality basically. Okay, whose center is at 2 comma 2. Okay, if I write this one, then it will become x minus 2 whole square plus y minus 2 whole square less than or equal to 1 square, which is 1. Okay, which means if I draw a circle with 2 comma 2 as radius and 2 comma 2 as center and 1 unit radius, then all the area within this circle is my possible solution set. Okay, so this is what I'm trying to tell. This green area is my solution set from the first inequality. Okay, now what is the next one? We need to find out the maximum value of 3iz plus 6 modulus. Okay, so how do you get 3iz plus 6 modulus? If I take 3i outside, modulus of 3i outside, then it will become z plus 6 by 3i, right? So modulus of 3i is nothing but 3 and modulus of z, and here 6 by 3 is 2 and 1 by I is minus I, so z minus 2i. Okay, now this is also equation of a circle of unknown radius, right? So which means its center is at 0 comma 2. Okay, its center is at, this is nothing but x square minus x square plus y minus 2 whole square equal to some r square, right? So which is 0 comma 2 as the center, which is here, 0 comma 2 is here. Okay, which is in line, straight line actually. Okay, it is parallel to the x-axis, this line is. Okay, of unknown radius. Now the question is, if you have a circle at 0 comma 2 as center and this green area is your solution set, what is the biggest maximum value you can, maximum circle which you can draw, okay, to a point where, what is the maximum point where it is a plus ib is attained? Okay, that maximum point is a plus ib. Where is that? Okay, so that is simple. If I draw a line from this 0 comma 2 and center of the circle, it will go and hit on the other side of the circle because this is diagonal, right? Okay, this is the maximum distance, right? This is the maximum distance in a circle. So maximum distance is possible at 3 comma 2 point 3 comma 2. I will attain the maximum distance for modulus of 3iz plus 6. Okay, so if once you understand this one, this is very simple, right? 3 comma 2 is place where I will attain the maximum value of this circle, imaginary circle. So a plus 3 by 3, a plus ib equal to 3 plus 2i, which means a plus b equal to 5. This is the answer. Next. Okay, let the lines 2 minus iz equal to 2 plus I z bar, okay, and 2 plus I z plus I minus 2 z bar minus 4i equal to 0, okay, where I square equal to minus 1 be normal to a circle. Okay, if the line, okay, iz plus z bar plus 1 plus I equal to 0 is tangent to this circle, then its radius is what? Okay, so first find out these two equations, okay, and then let's see what we will get. Okay, let z equal to x plus iy, so z bar equal to conjugate is x minus iy. Okay, now 2 minus I z equal to 2 plus I z bar. This is nothing but, if I expand it, okay, this is what I'll get, and if I simplify, I'll get a equation of a line x minus 2y equal to 0, x minus 2y equal to 0. This is a line. Okay, and the second equation which is given is this one. Okay, 2 plus iz plus I minus 2 z bar minus 4i equal to 0. If I simplify this also, I get another line equation x plus 2y minus 2 equal to 0. Okay, now he's telling these two are normal to a circle C. these lines are normal to a circle C. What is the meaning of this? Means intersection of these two lines is the center of the circle. Okay. So if I solve these two lines, okay, I get x equal to 1 and y equal to half. Okay. So 1 comma half is my center of the circle. Okay. This is my center of the circle. Now come to the point, where is the tangent? Okay. Tangent line is IZ plus Z bar plus 1 plus I, which is equal to 0. If I expand it, what I will get is Ix plus I square y plus x minus Iy plus 1 plus I equal to 0, or I get a tangent which is x minus y plus 1 equal to 0. Okay, this is my tangent and this is my center. Okay, now the question is, it's a radius. Radius is nothing but from the center, minimum distance is the uh, radius, because radius is always perpendicular to the tangent, right? So which we can get very easily. We have to use this formula. Okay, so distance from a point to a line, any line, okay, is nothing but this formula you have to apply. You put the point inside that equation of the line, modulus of that one, then divided by coefficient of x and coefficient of y squares, sum of it. Okay, so you will get 3 by 2 root 2. Okay, so this is the radius and this is the answer. Next, let Z be those complex numbers which satisfy two equations, which is one is modulus of z plus 5 is less than or equal to 4, and z times 1 plus I plus z bar times 1 minus I greater than or equal to minus 10. Okay, where I is equal to square root of minus 1. If the maximum value of modulus of z plus 1 whole square is a plus b square root of 2, then what is the value of a plus b? This is almost the same as the first problem which we have done. Okay, so let's do it again. So it's a good practice. So if you see, this question came in 2021, multiple exams you have, right? Multiple sessions. So 2 times, which means a similar problem is very high chance of getting at least once in the next exam. Okay. So z is, let's say z is x plus iy, then absolute z plus 5 less than or equal to 4 is nothing but we know x plus 5 whole square plus y square is less than or equal to 4 square, which is a equation of a circle with center at minus 5 comma 0 and radius as 4. Okay, once you know this one, let's check the next one. Okay, z plus 1 plus I plus z bar into 1 minus I equal to, okay, x plus iy into 1 plus I plus x minus iy into 1 minus I, which is greater than or equal to minus 10. Okay, if I simplify, what I will get is a line equation x minus y greater than or equal to minus 5. Okay, so this is a linear inequality bounded by a line x minus y plus 5 equal to 0. Okay, this is the line. If I draw, I have to take the values which are greater than or equal to minus 5. Right, or x minus 5, x minus y plus 5 should be greater than or equal to 0. That's a part I have to take. Okay, so this line passes through minus 5 comma 0 and 0 comma 5, so we can easily draw this on a graph. Okay, so if I draw this, okay, first one is the red one is the circle, okay, with center at minus 5 comma 0. This is x-axis, this is my y-axis, minus 5 comma 0 center and radius of 4. So it will go through points P, which is minus 1 comma 0. Okay, and then this side minus 10 comma 0 also possible. Okay, now this is the circle and a line I am drawing here, which is x minus y plus 5, which I know that it will go through 2 points I need, right? One is 0 comma 5, other one is minus 5 comma 0 here, center of this one. Okay, so it is going through this one. Okay, now once I know this one, okay, we can find point AB. What is the point AB? By solving these two equations. So I have to substitute x minus y equal to, or y equal to x plus y. If I substitute, I'll get the answer, right? So which is x plus y equal to y. If I substitute in this one, I'll get y square plus y square equal to 4 square, or y equal to plus or minus 2 root 2, and x is minus 5 plus or minus 2 root 2. Okay, so my points A is this one. A is minus 5 plus 2 root 2 comma 2 root 2. Okay, look at which quadrant it is, in third quadrant. So y should be positive, so I took y as positive, and x is negative, so this one, and b equal to minus 5 minus 2 root 2 minus 2 root 2. Okay, so because both x and y are negative here, so this is the one I took. Okay, so these are my a and b's. Now what is telling is maximum value of z plus 1 whole square. Okay, z plus 1 whole square is another circle with center at minus 1 comma 0. Where is minus 1 comma 0? This is exactly on the circle only here, p. Okay, this is on p. Okay, now I need uh, the value in such a way that this is maximum. Okay, so what is the maximum? Okay, I have to look at the only shaded area because this is where x minus y plus 5 is greater than or equal to 0, right? So I have to look at only this shaded area. In this shaded area, what is the longest distance? Okay, that is obviously b. B is the longest, right? So PB is my distance. This is my longest distance. PB is nothing but a plus b root 2. Sorry, not root b. A plus b root 2. Okay, so p is minus 1 comma 0 and b we know already. Okay, so if I see this is b root 2 actually, not root b. It's given as a plus b root 2. Okay, so we can write it as b root 2. Okay, so pb square is nothing but this is the value. Okay, so 32 plus 16 root 2. Okay, now my a is 32, b is 16. So a plus b equal to 48. This is the answer. Okay, hope you understand. This is a similar problem as first problem. Okay, just to do it carefully, draw the rough graph. Very easy to draw the rough graph once you know the points. Okay, and I think you should try these problems more because they keep coming in JEE. At least one problem. Okay, next. The least value of modulus of z, where z is a complex number, satisfy the inequality x exponential of the expression given here. Okay, the expression given here greater than or equal to log of modulus of 5 root 7 plus 9i to the base root 2. Okay, so thing is, yeah, we need to just simplify everything first. So RHS looks a very simple modulus. So let's simplify the RHS first. Okay, so RHS equal to log and modulus of 5 root 7 plus 9i is nothing but square root of 5 square into 7, which is 25 into 7 plus 81. Okay, square root of, and then to the base square root of 2. Okay, so this is nothing but uh, log of square root of 2 square root of 256. Okay, directly you can write this answer is 8. Okay, 2 to the power of 8 is 258, so answer is 8. Or you can directly convert into this is nothing but your 16, which is 2 power 4. This is 2 to the power of half, so 4 by half, which is 8. Okay, now RHS is 8, which we are clear. So this whole expression is greater than or equal to 8. Correct? Now let's say instead of every time reading this, let's call this expression as y. Okay, if this is y, this expression is exponential of y log 2 to the base e equal to, which is nothing but e to the power of, exponential means e to the power of log e 2 to the power of y. Okay, y I am taking to the 2 to the power of y. Okay, product, right? So which is nothing but 2 to the power of y. Okay, so this whole LHS is nothing but 2 to the power of y. So 2 to the power of y is greater than or equal to 8, which means 2 to the power of 3, which means y is greater than or equal to 3, right? So now my y is this one, this whole expression. Okay, greater than or equal to 3. Now look at the expression. Now it's the time to look at this. This is nothing but, if I call absolute z as x, this is nothing but x plus 3 into x minus 1 divided by x plus 1. So obviously I'm getting a quadratic equation here, right? In modulus z. So if I expand it, it will become z square plus 2z minus 3 is greater than or equal to 3 modulus z plus 3, or z square minus modulus z minus 6 greater than or equal to 0, which if I factorize, I'll get modulus of z minus 3 into modulus of z plus 2 is greater than or equal to 0, which means z is outside 3 and minus 2 comma 3, right? So modulus of z is greater than or equal to 3 and modulus of z is r, and modulus of z is less than or equal to minus 2. Modulus cannot be negative, so we ignore this one. Okay, so minimum value we get is modulus of z is greater than or equal to 3, which means, right, minimum value of modulus of z is 3. Okay, next. Yeah, If f of x and g of x are two polynomials such that the polynomial p of x equal to f of x cube plus x times g of x cube is divisible by x square plus x plus 1, then p of 1 is equal to. Okay, just check why this problem is in complex numbers. Okay, there is nothing mentioned about complex number here, right? It's just functions and maybe polynomials. So why it is there? Okay, so don't forget the basics of complex numbers. This is nothing but the roots of this equation is omega and omega square, which are cube root of unity, right? Cube root of 1, you have three roots, 1, omega and omega square. Omega and omega square come from this expression. Okay, if you just find the root of this one, -1 plus or minus I root 3 divided by 2, right? This is nothing but omega and omega square. Those are the values. So that's where complex number part is coming. Okay, so let's see now. First, p of x is given as f of x cube plus x times g of x cube. So I'll first take 1, which is simple, right? P of 1 equal to f of 1 plus g of 1. So I need to find out p of 1, which means I need to find f of 1 and g of 1. That's it. Okay. So how do you find p of 1? P of x is nothing but given as some q of x, and it is divisible by x square plus x plus 1. Okay. So it is divisible by x square plus x plus 1. Sorry. Okay. 1. Which means p of x, for p of x, omega and omega square both are roots of p of x, right? So p of omega is nothing but f of omega cube plus x times g of omega cube, which is equal to 0 because it's a root, right? Omega is the root of p of x. So omega cube, we know it is 1. So this will nothing but f of 1 plus omega g of 1 equal to 1. This is one equation for me. Now I will take p of omega square, which is nothing but f of omega to the power of 6 plus omega square into g of omega power 6. So we know again omega power 6 is 1. So this is nothing but f of 1 plus omega square g of 1 equal to 0. Now I have two equations. Okay. If I do E1 minus E1 plus E2 first, okay, this will give us 2f of 1 plus omega square g of 1 equal to 0. So from cube root of unity, we know that omega plus omega square is equal to -1. So which means 2f of 1 equal to g of 1. Okay, so this is one information for us. Now E1 minus E2 give us omega minus omega square times g of 1 equal to 0. Now omega minus omega square cannot be 0. So obviously g of 1 has to be 0. If g of 1 is 0, if I substitute here, f of 1 also 0. Okay, so now g of 1, f of 1 is 0. So now what is my p of 1? P of 1 is nothing but f of 1 plus g of 1, which is also 0. Okay, so this is how we have to solve this problem. So look at the key indicators, okay, from the problem that will give you an idea, okay, where this problem belongs to. Okay, x square plus x plus 1 in this case is very important. Okay, hope you understand these critical problems. Okay, yeah, that's all for today. I'll come up with more problems. Keep doing maths until then. Thank you.